So exercise 2, in this case I use Excel. You can see my Excel window. I simply use Excel to actually enter all the values as a table. And now I need to save this table as a CSV file, not as an Excel file, but as a CSV file, right? So I simply use File, Save As, and then you can see that I already have selected this, right? So, but that's a lot of different formats you can use. This is a standard Excel book, and this is a CSV, comma separated, comma delimited values, right? So I simply select this one, and then it's important that you save your file into the same folder where you have all the code devoted to this lesson, to this exercise. I will simply save it on desktop, but and then I need to upload it to server because I use RStudio on server. But you have just simply to save it to the same folder where you have the scripts, the R scripts. That's important. So I don't need Excel anymore, so I simply close it. And then you can see that I already have it here. So people CSV. Okay. So now exercise 2. Let me show you how to solve exercise 2. So again, I'll start with task 1. And then the task 1 tells me enter data from the table to Excel sheet and save it as CSV file. And then that's what I actually already done. So I will means that I have to start with task 2, right? Not task 1. So the task 2 tells me import data from the CSV file to data frame. So first of all, I wonder how my CSV file looks like. So let me open this CSV file as a text file. Just click View File. It's very important before you open it, don't change it. Don't change anything inside. Open it, look at it, and then close it, because otherwise you can actually destroy it. Also, don't open it in Excel. Open it inside RStudio. Okay, so let's look at my file here. So you can see that because I use Excel and because my settings, my original settings are Danish settings, so I have Danish language as a main language. So you can see it's not comma separated, it's semicolon separated values, right? So I don't have any decimals here, so therefore you don't see the decimal separator, but I know that in this case decimal separator is actually comma. So now I know what kind of CSV file I have, and now I can actually select a correct function for that. It's read CSV2. But before I actually do that, let me do two things. First of all, let me get rid of this one, so I don't need this anymore. It's from previous exercise. And second, let me make a wrong choice, right? So let me try to read this file using a wrong function. Read CSV, and then file name. Again, I use tabulator to see all files in my folder, and then select the needed one. Otherwise, you can just write it, type it. Let me run it and see what happens. Now look, I got D. I didn't get any error message. I got D. But I got D as 10 observations in one variable. So I expect to have at least 3, and then I also have names, right? But now I got it as one variable. Let's see what is inside. Inside, I have a very strange variable name, x.height.weight.gender, and then you see it's a vector. So it took every row and just loaded as a text value. Okay. And in R, there is for data frame is a nice feature. There is a nice feature here. You can see a little icon. You can open a data frame and see it as an Excel. You see the tab here, and then you can see I don't have 4 columns. I have actually 1 column with all this data like concatenated, merged. Because R think in this case that separator between values it's comma. It cannot find comma here, so it thinks it's one value only. The solution here, it's either write explicitly what separator is, so I can just write separator equal to semicolon, or alternatively, you can just use a special shortcut, which is called read CSV2, which assumes that separator will be semicolon. So if I run it now, you can see I got it almost correctly. Now I got this D as 10 observations of 4 variables. The first variable is X, very strange, I don't have X variable in my table. Then I have weight, gender, and height. And you can see that in this case, height and weight were loaded as integer values, not just numbers, but integer values. And then it doesn't really matter. And then gender is numeric. Yeah. Again, if I click on this button and open it, you can see I have names as separate column. Why I have X here? Because in my original Excel file, I don't have any variable name for names, because it's not variable, it's names, it's row names, right? but this is how by default readCSV reads the data. Luckily, I can tell readCSV the first column in my data is not data, it's names of the rows. This is how to do that. I simply write row names equal to 1, because in this case I indeed have row names. So if I run it, now everything is read correctly. So you can see I have only 3 variables, not 4. Where is the names? If I click here, you can see that now we have names correctly. So these are the names. So I have row names. Okay. So if I type D here, you can see this as well. So you can see height, weight, gender, and then you can see Bob, Lena, Peter, Klaus, Anna, and so on. Now, so that's the first, or task number 2, how to load CSV data. Now what we need to do in task 3. In task 3, we need to calculate BMI again, and then we need to add it as an additional column of this data frame. Yeah. So let's do that. First of all, let's calculate BMI, right? So BMI is, in this case, I don't have separate vectors, height, weight, and gender, right? I have these vectors as a column of data frame. But luckily, I know how to get values from these columns. I need to write a data frame name, then I need to write $, and then you can see RStudio helps me. It shows me all columns of the data frame D. So I simply select weight, divided to parentheses, $, again height, divided to 100. So I simply use the same formula as I used here in the previous exercise, but now instead of height and weight, I use $, weight and $, height, because now height and weight are not just vectors, they are columns of data frame D, right? So if I run it, I will get BMI, and I can round it because it was also part of this task, round it to 1 decimal. Again, I use similar, I just use round in the same line where I do the calculations. So now if I look at the BMI values, they seem to be correct. Now, the only thing I need to do, is just to add this column to the data frame D. Again, there are several ways to do that. I can just write, I can use cbind, for example. I can write like D equal assigned, and then cbind D and BMI. Yeah? And that will work. Look at this. Now D has this additional BMI. The problem with this solution is that if I just run it again, I will get another BMI column. If I run it again, I will get another BMI column, right? So every time I run it, it takes D and add BMI to D. Right? So I have to run it from the scratch, so I need to refresh my D. Right? But that will work. Alternatively, what I can do, let me remove this code. I can do it like this. I can write D $BMI. And since I don't have column BMI, in this case, R will understand it and it will add this column automatically. So like this. So now you can see I got BMI column here. So let me just run it from the scratch like this. So you can see I have BMI column here. And now if I do it again and again and again, of course I didn't get the column because it just reused the column that I already have. Yeah. So it means that actually I don't need to produce this vector BMI. I can just write D $BMI in the beginning, right? I don't need it separately. I don't need this vector separately. So if I remove everything and then run these 2 lines, so I will get BMI already inside the data frame. Okay, so that will save some code and also make it a little bit more clear. Now the next task, I need to split my data frame into 2, one for males and one for females. So task number 4. And we know that if you want to split data frame by rows, so some rows go to one place, some rows to go into another place, the best thing you can do is to use function subset. So that's what I'm going to do as well. I simply say F, short for females. It's a subset of data frame D. How to make this subset? Actually, simply compare gender with, take all rows where gender is equal to F. Yeah? And then similarly here, M, data frame D, gender equal to M. Yeah? So if I run it, you can see I got 2 additional data frames. In each I have 5 observations, so I have 5 males and 5 females. Then you can see I still have 4, and then that's what is inside. Yeah? Now look, you can see that gender is constant in F and is constant in M because they are all males and females. So strictly speaking, gender is not needed, right? I can tell R, don't get gender column to this data frame F and M. To do that, I need to specify additional argument. I just need to use additional argument. It's called select. Select tells which columns to select. So in this case, I can say select columns height. You can see I don't use quotes here because it's like variable names. It's like column names. And then BMI. So I skip gender. Yeah? Then I can simply do the same thing here. And if I run everything from the scratch, you can see that I don't have gender column in FNM. So it was redundant. I didn't need it. So that's why I think it's a good idea to remove it. Okay. It was not a part of exercise. It's just a little bit extra. So also aware of this possibility to select columns when you make a subset. Okay. So now we have these subsets. Now the next task number 5, is to compute. There is one more thing I forgot. When you use subset, your row names are kept. So if you click on this little icon here, then look at what you have here, you can see that the row names are kept. So you can see these are only female names, and then the same for males. Alternatively, if you can also see it here, right? Males, females, and males. Okay. So task number 5. In task number 5, I have to compute average value for all numeric columns of each data frame and show the computed values as named vectors, right? There is a way to do it in a very nice way, in a short way actually, but let me start with a long one. Okay, so I need to calculate average height for females and average height for males, right? So I can say I can do it like this. I can say mean height for males is mean. That's the function that calculates mean, and then I say $m height, right? So that calculates average height for males, right? You can see it here. It's 170.6 centimeters, right? Then similarly, I can say average height for females, mean, and then F for height. Yeah, like this. So you can see that it seems like females are a little bit taller than males in our case, right? And then to calculate the average weight, I can do it this similar way. So I can just say average weight for males and average weight for females, and then use weight instead of height here. Weight instead of height here. So I can run it, and then you can see this is weight and height for females average, and this is weight and height for males average values again. Now I can actually show these values, and I can actually make a data frame from these values. Let me show you how. I will create a data frame stat. I say it's a data frame with 2 columns only. The first column will contain the average values for height, and then it will be a combination of 2 values, mean height of males and mean height of females. And then I say weight, and it shouldn't be here. I should use equal sign. That's a mistake. So inside functions, the data frame is a function. Inside function, when you specify argument of the function, always use equal sign, not this arrow. Always use equal sign. That's a mistake. So I say again, combine into a vector average weight for male and average weight for female. Right? Now, that's one thing. And if I run it and then I say show stat, you can see indeed I have a very nice table, height, weight, and I know that these are males and these are females, right? But let's make row names, corresponding row names for that. So row names, stat. I know that the first row is actually the females, right? So it's males. It's males. I'll say males. Then the second is females. And that will give me a very, very nice output. So I can see that this is a height and weight. These are males and these are females. Of course, I can also write something like this. Cat, like new line, average values for groups, for example, right? Then new line again. And that's sort of, if I click source, you can see average values for groups, height, weight, males, females. So that's a very nice output here. Okay. So that's a little bit different from what I actually asked it in the task 5. I told you to show the computed values as named vectors, but I think that this way to do that is a little bit more complicated, but it gives you a little bit nicer output. Okay. And then finally, exercise 3, it's very similar to what you have already, but you need to change only this part. So instead of reading data from CSV file, you have to read data from Excel file. So I will only complete this part, how to read data from Excel file. Okay. First of all, I go back to Excel and I go back to my previous table, people. And now I need to And now I need to save this table as Excel file. However, there is one important thing. Excel, when you read Excel files using function read Excel from this package read Excel, you cannot specify row names. So you have to get this data as a set of columns. Okay, so therefore I need to make this as a column. So I will simply say names. So now it's a column, it's a part of my data. And that's actually it, right? I can also see that it spans the range from A1 to D11. It's not needed because I have only one sheet in this case, and I have only one table on this sheet, but just to show you how it works, okay? So now I will save it as Excel file. I will save it not as a text file, not as CSV file, as Excel file, also on desktop, and then I will upload it to my RStudio. You don't need to upload, you just need to save in the same folder as you have here, right? So now let me show you how to do this one. First of all, I need to install a package which is called readXL. This package will allow me actually to work with readXL files. So I click install. Alternatively, you can just write install packages, right? So and then I say readXL. So you can see there is a package like this with this name. If I click install, you can see that actually RStudio runs this command. Let me go scroll up, install packages readXL, right? So it install a lot of things because this package depends on many other packages. You can see a lot of different packages. Just strictly speaking, you don't care because, I mean, all packages are located in the same space, in the same place. So when you, for example, remove RStudio, they will be also removed. And you can see the installation takes some time. It does some computation, it does some compilation of code. So it will take some time. But luckily you need to install it only once, and while it's installing, I will just start writing the code. Well, first of all, you remember, if I want to use a package, the good idea is to load this package with library. It's not necessary, strictly speaking. I can use this prefix package name and 2 colons, but I think it's nicer when you load the package, so you don't need any prefixes at all. So I say library readXL. In this case, I don't need quotes because it's like a variable name, package name. And then I can simply say d equal to readXL. This is the function, and then simply a file name. So in this case, I don't need to specify anything, XLSX, right? So let me wait until the installation is over. So now you can see it's done. No error messages. Now I hopefully can use it. Yeah? First of all, I will remove all my previous variables here, and then I just click broom. And then you can see it's removed. And then I load library readXL. It loads the library. And then you can, if you click here, you can see actually which libraries you already loaded. You can see that that's the last library that I loaded. It's a package readXL. You can see by default R also loads a lot of packages like base, methods, datasets. Actually, all packages that you see have this checkbox here, checkbox here. They will be loaded automatically. Okay, and global environment is what you actually work with. Yeah. So now I can just try to read the file. You can see D, and then I got it, right? So if I look at D, you can see that it looks a bit weird. Yeah, it doesn't look like a data frame. It has some additional information. You remember I told you that this function doesn't return it as a data frame. It returns it as a table. Table is like a data frame on steroids. It's a little bit more advanced form as a data frame. So let me just convert it to a data frame. So to convert it to a data frame, you simply use a function sDataFrame, and then the same. So it will take D, convert it to a data frame, and save to D as well. So if I run again, I don't need to run library anymore. It's already loaded. I run these 2 lines, and then I look at the D, and now you can see it's an old, good data frame. Yeah. The last thing I can do is I can get rid of this column and use this column as names. In this case, I need 2 steps. First of all, I need to define names, right? I need to say row names D, where I got the row names from the column names, right? So I say D $names. Yeah. So if I look at D, you can see I have names here, but I also have this column. Luckily, I know how to get rid of the column. You remember, I can use these negative indices to get rid of the column. I say take D, remove column number 1. I can actually do it like this. Remove column number 1. You remember, if you specify only one index here, it means that you specify which column you work with. And -1 means everything but not the first column. And then I save result to variable d again. Yeah. So now I need to run the whole code from the scratch. Then you can see now I have 3 variables inside. Looks nice. Numeric, numeric, character. And then if I look D, now I have a data frame, 3 columns and names. So you can see that if you use, if you want to read directly from Excel, you need to do a little bit extra, especially if you have row names. But other than that, it's pretty straightforward procedure, and it works everywhere. Also, if you don't have Excel, for example, as I said, I run this RStudio on Linux. There is no Excel on Linux, but you can read Excel files in Linux anyway. Okay, so that's it. Now you know how to actually work, how to represent data in R, and how to do some simple calculations. In the next set of videos, we will discuss how to make plots.